Starting the video. Today we're going to do the matrix multiplication or product of matrix. Product's just another name for matrix multiplication. Okay, so today the matrix multiplication today is actually going to be when you multiply a matrix with another matrix. Yesterday we just did scalar, which meant we just multiplied by a number. So what you're going to get is you're going to get two matrices that you're going to be asked to multiply with each other, okay? Now, when you do matrix multiplication, the order of the matrix is very important because some can be multiplied together and some can't. There's some particular rulings. So if you say here in the example, if we have matrix A here, it's going to have its own order. So I'm going to put an example here. So I'm going to say pretend matrix A had an order of a 2 by 3, okay? And then I'm going to say matrix B had a order of 3 by 4. So for you to be able to multiply two matrices together, the number of columns in the first matrix, so can you see here? So number 3, that would be the columns, wouldn't it, in the first matrix, has to equal the number of rows in the second one that you're multiplying. So can you see that those two numbers are equal? All right, so for you to be able to do it, those two numbers have to be equal. And they will ask you to explain. Sometimes the question is, why can this be done? And you need to actually write this statement out. So you can multiply these two matrices because the number of columns in the first matrix. Now, just in this example, it's called A. It might be called something else in yours. Must be equal to the rows in the second matrix. Okay, that's all you need. That's the statement you need when you need to prove that it can be, multiplied. Okay, so then you get the answer of that matrix. So sometimes they've called it matrix C. Sometimes they might say that it's AB. Yeah, you've times the two together and you've created this new matrix. Now, can you see what your answer is going to be? It's going to have the rows of the first matrix. So for this example, this one's going to have a 2, and it's going to have the columns of the second matrix there. So in this example, it'll have a 4. So first of all, so we have to practice making sure, can we actually multiply them together? If you do it on the calculator and it's not, so what we call when they're equal there, we call that defined. Okay, so it's, we'll say it's defined if it can be multiplied. So we need to firstly ask, if you do it on the calculator and there's two matrices that cannot be multiplied together, your calculator will just spit out, I think it might even say undefined, it says the word. If it can be done, it will do it and produce the answer for you. But we need to know how to manually do it, so do it without the calculator. All right, so let's just go check and see if we understand that rule. So what we're saying down here is the general rule. So what we're saying is these two must be the same, and that's called defined when they are. And the answer is going to have these two numbers. So your new matrix size or order will have that. Okay, so if we have a look at, I'm going to go and do these examples over here. So what they're asking you, which of the following are defined, and if they are defined, what will their order be if you multiplied them together? So can you see if I do matrix A times matrix B, so what is the order of A up here? So looking up here, what's the order of this one?
2 by 2.
Good. This is a 2 by 2. What's the order of this one?
1 by 2.
1 by 2. And this one? 2 by 1. Good. So underneath, if you wrote the orders, it's a 2 by 2 and B is a 1 by 2. These two numbers are not equal, are they? No. So this one's not defined. Okay? All right, if we do the next one, if we do a B, B was 1 by 2, and I multiply it with A, which was a 2 by 2. Now, can you see that can be done, can't it? Yeah. So can you see with matrices, order is extremely important. And what I mean is which one's first and which one's second makes a difference, doesn't it? Yeah? Because A times B couldn't be done, but B times A could be done. So this one is defined. Okay, so we know it's defined because the columns in the first one equal the rows in the second. Now, what will the order be? Yeah, so if I write matrix BA, it's going to be this number here, isn't it? 1, and that number there. So it's a 1 by 2. Good. All right, let's go do the C one. So we've got matrix C, which is a 2 by 1, multiplied with B, which is a 1 by 2. So is this one defined? Yes. Yeah, good, defined. And what will its order be, the answer? So CB will be a 2 by 2, good. All right, and let's have a look at if C and A. So C is a 2 by 1, and A is a 2 by 2. Is this one defined? It's not defined, is it? Not equal. So that was equal. So this one not equal, not defined. Okay, so as we discovered there, we saw that when we multiplied matrix A times matrix B, it was not the same as if you do B times A, isn't it? Because remember before we saw that one time A times B was not defined, but B times A was. So what we're saying, the order of the way you're multiplying these matrices is important because they will give a different answer, okay? So in normal maths, that doesn't happen, does it? Like if I say 2 times 3, you say it's 6. If I say 3 times 2, it's still 6. But that's not the case in matrices, yeah? Matrices is a thing where it is important. Whichever one comes first, if they're saying multiply that one by that one, you have to be careful on the way you do it. All right, so we are not going to do manual multiplication of very big ones, only small ordered ones. And the maximum that you would get is, like the biggest one you're probably going to get is maybe a 2 by 2 with a 2 by 2, okay? So let's show you. I'm going to zoom in, sorry, because it's a bit small for me. And I want you to see this. All right. So, first of all, so if I come up here, I've got these two matrices here. Okay, so I've got the two matrices there that I'm going to multiply. All right, so what we're going to do is first we're going to check if it's defined. So the order of this one is a 2 by 2, good. And this one is a 2, good. So, yes, it's defined, so I can do it. And isn't the order going to be a 2 by 2? So you can see what I'm going to do is create this 2 by 2. So what I often do is sketch out a matrix and I put the 4 boxes because that's where those 4 elements are going to go because it's a 2 by 2. Does that make sense? It would have 2 rows and 2 columns. All right, so can you see the way they do it when you multiply matrices is that you go, what they often say is that you go run and dive. So what is happening is that A is getting multiplied with E. So can you see that there? and then B is getting multiplied with G, and you can see that there, and they're adding it together. Now that gives me the first element. If I was looking at this little box here, what row is it? If this little element here, what row is it? Row 1, and what column is it? What column is it? No, this is row 1, row 2. This would be column 1 and column 2. So what column is it? 1. So can you see when I worked out that answer, I used row 1 and column 1, didn't I? Oops. Can you see that? So what do you think you'll use here to find this one? What row is it in? It's in, what row is it in? Row 1. Rows are these way, yeah? Row 1. And what column is it? So column 2. So can you see if I go to do this one here, I'm going to go run and dive. Does that make sense? So can you see, I'll do it again. A is getting multiplied. Wait, let me rub this out a bit. Okay, so we've done we did this first one here. Okay, so now I'm going to show you how we find this one here. This is the answer. So remember we said it will be a 2 by 2 because this was a 2 by 2 and this was a 2 by 2. Okay, so because this element is row 1, column 1, see row 1 and column 2, that's the ones I'm going to use. So I'm going to go row 1, run. So sometimes they call that run. And then you dive. And I'm using column 2. So can you see I've used row 1 and I've used column 2. That's what I'm saying here. Okay, so what you do is the A gets multiplied with the F. So can you see AF? And then you add B multiplied with the H. Okay, and you've added it there. That's how you find that number. All right, so down here, if I do this one down here, what row and what column will I use? I'll use
row 2, column 1.
Row 2 and column 1. Good. So you're going to go this row with this column. Okay? And that's how you wrote. So you do the C with the E and then the D with the G. Okay? And add them together. So we'll go and do an example of that. And that's what I'm saying. This one you might have to watch again because it's getting thin. So let's, just zoom back out. Okay, so over here, I'll do the example. All right, I'm going to multiply A with B. Okay, so first I might just write it out as actual matrix. Okay, so what is the order of this matrix? This is matrix A. What's the order of this one? 1 by 3, good. And this is matrix B. What's the order of this one? 3 by 1, good. So it's defined, isn't it? Yeah? And what will the answer be? What will the order be? Good, you're saying 1 by 1. All right, cool. So it's a 1 by 1. So I'm just going to put the answer down here. So if I have a 1 by 1, I essentially have one row and one column. So I'm really getting one answer there, aren't I? Yeah? So let's go, what we would do is we'd go row 1 with column 1. So I'm going to say it's 1 times 3. So that one with that one. Plus, what do you think the next one is? 2 by 4. Plus, what will the last bit be? 3 by 1. Yeah? So I'm taking that row, flipping it and multiplying it with the column, and they'll match up. So then you tidy that up. So that would be 3 plus 8 plus 3. So add them all together. What do you get? Pardon? 14. And is that a 1 by 1 matrix? Yep, and we've done it. Okay? So you won't get too big. We just need to practice small ones and take our time. So just here, this is taken out of the exam tips for VCE, and it says a student needs to be able to articulate why two matrices may not be conformable for multiplication. So what does that mean? That just means this means down here, you need to be able to say whether it's defined or not. And what do? You just say the number of rows, number of columns in the first either does or does not match the number of columns in the second. So if it can't be done, you say because they don't match. If it can be done, you say they do equal. Yes? Okay, and then it says many students have illustrated poor understanding of the need for the number of columns in the first. See, that's what they need. They need the number of columns in the first matrix has to be the same as the number of rows in the second. Okay, so that's what they're looking for this year and next year. Yeah? All right, they want me to multiply these two matrices together. First, I'm going to check if it's defined. So let's put the order of this one. What's the order of this one? 2 by 2. And what's this one? 2 by 1. Okay, so yes, it's equaled, so it's defined. So what they were saying before in that examiner's note, I can't just write that if they want me to explain why I can do it. If you're asked to explain, you have to write all that wording out, yeah? But for me just checking if I can do it, I'll do it like that. Now what will my order be? It'll be, all right, so I'm going to get a 2 by 1. So what I often do is I do my matrix. And now it means I'd have 2 rows and 1 column. So I just put in there little spots for my 2 elements. So here's row 1, here's row 2, and this is column 1. Okay, that's what I'm going to have. So let's do this one first. So I'll do this one in green. It is row 1 with column 1. So I'm going to have 1 times x plus, what will it be? 3 times, good. And then I do the second column. So I'm in second row with column 1. I'm going down that way. So I'm going to have, so I'm doing this one. So I'm going to have 2 by what? The 2 with the first one, x, plus -4 with y. Now, so if I tidy this up, can you add x and y together? Nah. So you're going to end up with x plus 3y. That's okay. We'll just leave it like that. And what will the bottom one be? 2 times x is? And -4 times y. So you'll leave it like that. So this will be your 2 elements. They're your 2 elements there. All right.